Hello everyone, welcome to Career Launcher. My name is Naveen and today we will be doing basic numeracy of CSAT 2025. So we have just begun with our new batch of CSAT. So today is the first video session and in this we'll be solving some of the questions and also we are going to talk about what are the offerings we have brought. So it's going to be basically an orientation class for you guys. So at Career Launcher, we believe in imparting the best knowledge uh, in the best possible way, in the easiest possible way. We do not rely on forcing students to learn formulas. We teach them the concepts. We start from the scratch, and we have immense patience when it comes to doubt handling. Okay, so let's look at some of the questions and see how at Career Launcher we teach, okay, how we explain the concepts. Maybe that will help you understand what we offer. So the first question is, a bag contains coins of 1 rupee, 50 paise and 25 paise in the ratio 2:3:5. The total worth of the coins in the bag is rupees 332.5. What is the sum of the number of 50 paise coins and that of 25 paise coins in the bag? So these ratios that you see here, it tells you that you have these many 1 rupee coins, you have these many 50 paise coins, and you have these many 25 paise coins. So we can use the approach when what we have done way back in our school days, or we can do an assumption approach, which is relatively easier because we don't write a lot of equations because we will not have those many variables. So we're going to assume that we have two coins of 1 rupee. So if we have two coins of 1 rupee, the amount that it is going to make is going to be rupees 2. We have three coins of 50 paise. So if we have three coins of 50 paise each, the amount that these three coins are going to make is going to be 1.5 rupees. And then we have five coins of 25 paise each, such that the amount that it is going to make is going to be 5 times 0.25, or we can say 4 coins of 25 paise will make 1 rupee and another coin of 25 paise will make another 25 paise, that is 1.25. So the total amount now that we are going to have is going to be 4.75. So this is everything based on the assumption that is given in the first statement. So what we have got is 4.75, but we are told that it's not 4.75, it's basically 332.5. So how many times is this? 4.75 into what will result in 332.5. The number of times this amount will become is the number of times each amount from each of the coin types we are going to have. So we need to find out the value. So 332.5 divided by 4.75. So 332.5, I'm going to ignore 0.5. I'm going to put 50 and then I'm going to divide it by 475. So 475 into 5. So it's not going to be 10 times for sure, right? Because 475 into 10 is 4750. We need 3325. So 475 into 5 is going to be approximately 2300, 2400. We need to go another around 1000, basically less than 1000. So we can go two more times. So 5 times plus 2 more times, it's going to be 7 times, and then we have a 0. So it is supposed to be 70 times. Now, we are asked, what is the sum of the number of 50 paise coins and that of 25 paise coins in the bag? So the number of $50 paise coins is 3. The number of 25 paise coins is 8. So the total number of both the types of coins we have is 8. Now, since this is getting 70 times, so which means everything will become 70 times. So 8 into 70, 8 into 7 is 56, and then we will have a 0 at the end. So 560 becomes our answer. So you can see that basically we did not write equation because we did not have variables. That's a good way to approach questions based on ratios. that you can assume those values that are given, and it helps us solve questions faster. Let's look at another problem. By selling toffees at a rate of 30 for 15, a man loses 4%. To gain 20%, how many toffees must he sell for 5? So this is a trick question. This is a manipulative question, but in English. So math-wise, there is no issue. So the missing part here is, instead of 15, there should be rupees 15. Instead of 5, this is going to be rupees 5. This is something which was implicit, as in you should know this already. Now, there is a formula, a very common one, which tells us price into consumption gives you the expenses or the expenditure. So basically, if you buy 3 bananas and each banana costs you 5 rupees, you will end up selling, you will end up paying 15 rupees, 3 into 5. That's exactly where this formula has come from or was derived. The second part, which is important to understand in this problem, is when it says 30 toffees for rupees 15, basically you pay the shopkeeper 15 rupees and you get 30 toffees instead of it. So the price is going to be 50 paise. 50 paise will happen if we divide 15 by 30. That will give us a half, or half can also be written as 0.5, which is going to be 50 paise. So here we can straight away see that the consumption, that is, we are buying 30 toffees, and the price, because he loses 4%, that means only 96% of the price was gained. Okay. Now, he must have spent something. Now, he wants to gain 20%. So that would mean he gains 120% now. And he must sell for rupees 5, right? So since the expenditure is 5 times here, the initial one, sorry, not 5 times, 3 times. Okay, 15 is 3 times of 5. So this was based on rupees 15 as the expenditure, while this is based on rupees 5 as the expenditure. So basically, what we need to do is we need to triple it so that this also becomes 15, and now we can equate it. How many toffees we are supposed to buy? Let's say we have no idea. Now, in order to solve this, the first thing that will cancel out is going to be the symbol percentage. Then 30 into 4 is 120. Now 4 into 3 is 12. 12 into 8 is 96. So we get the value of t is equal to 8. You can see that it was a one-liner equation. Okay, and equation was there because we had to bring in the variable t, which was the unknown part for toffees. Let's look at another question, which is a little more difficult than the standard ones because it's based on algebra. If alpha and beta are the roots of the equation x square minus 10x plus 21 is equal to 0, then what is the value of alpha square plus alpha beta plus beta square? So whenever you are given the 2 roots of a quadratic, the sum of the roots is given as minus of the coefficient of x upon the coefficient of x square. So this is nothing but 10. Product of the roots, that is alpha beta, is given as the constant term, which is 21 here, divided by the coefficient of x square, which is 21. Now, in order to get here, what we can do is, if we square this equation, we will be getting alpha plus beta whole square, that is equal to 10 square. The LHS will give us alpha square plus twice alpha beta plus beta square, and our RHS is going to be 100. Now we can rearrange it and write this as alpha square plus alpha beta plus beta square, which is asked, and then alpha beta separately, which is going to be 100. Or from here, we can write alpha square plus alpha beta plus beta square, and we will have 100 minus alpha beta. Now, alpha into beta is something we already know. So 100 minus 21 is going to result in 79. D option becomes our answer. So if you're keeping track of time we are spending in every question, it's not more than over a minute or a quarter minute over. Okay. So 60 seconds to 75 seconds is all you need. But for that, it is very important that you should know the concepts. You should know what actually to write. You should know, how to manipulate the question. That becomes very important. Another one. So question based on time and work. Pipes P1 and P2 together can fill a swimming pool in 18 hours. P1 is open into this empty pool and after 8 hours it was closed. And at the same time, P2 was open into the pool. After 12 more hours, it was found that the pool was half full. How many hours can P1 alone fill the pool completely? So here, I'm going to assume that this is the efficiency of the pipe P1. So basically, efficiency means how many liters every hour it is putting in water. And then this is the efficiency of pipe P2. You can add, subtract the efficiencies. You can divide the efficiencies. All of those are acceptable. You cannot add, subtract, or divide the time, right? So the volume of water that should be in the pool is given as efficiency into the duration. Now the same volume, not the same volume, actually half of the volume, right? It was half full. So we can say that half of the volume is also getting filled when P1 is opened for 8 hours alone, and then it was closed, and when P2 was opened, it worked for 12 hours. From here, our target is to find out what is the assumed value of P1 and P2. Why assumed value? Because if you watch carefully, there are 3 variables and 2 equations. We won't be able to solve the values for P1 and P2. We don't know the exact values of those, but we can definitely calculate the ratio, which is assumed values. For that, what I'm going to do is I'm going to write down, I'll take the V from here and I will half it so that I can equate. So my LHS is going to be P1 plus P2. 18 by 2 is 9, and we will have P1 into 8 plus P2 into 12. If I open the bracket and rearrange, I will have 9P1 minus 8P1, which is P1, and 12P2 minus P2, which is 3P2. Or we can from here say that P1 upon P2 is equal to 3 upon 1, which means P1 fills 3 liters every hour and P2 fills only 1 liter every hour. So if this is true, then if I put these values back in this first equation, we can find out the volume. So volume is going to be 3 plus 1 into 18, which is 4 into 18. Well, 4 into 18 is something we can calculate, but I would really not, would like you to calculate it. Leave it as such. We know the volume. We know how much water pipe P1 is pouring in every hour. We can find out alone how much time he is going to take. So 4 into 18 is the volume that P1 is supposed to fill at the rate of 3 liters every hour. And the time he is going to take is, let's say, T. So from here, we will have 3 into 6 is 18. So we'll have T is equal to 4 into 6, which is going to give us 24, which means P1 can fill this alone in 24 hours. Option A. So TSD question now. A motorboat takes a total of 5 hours to travel 21 kilometers upstream and 21 kilometers downstream in a river. If the speed of the stream is 40% the speed of the boat, then how long would the boat take to travel 30 kilometers upstream in the river? Excuse me. So basically, there are a couple of things that we should know. The first is time taken to move upstream. So time is given as distance upon speed. So distance upon speed upstream. And time taken to move downstream is given as distance upon speed downstream. Now, the thing is, speed upstream is when there is a boat, and if it has to move upstream, it has to counter the stream speed. So its speed reduces. So SB here stands for board speed, and R here stands for the river speed, or we can say the stream speed. Similarly for downstream, so if you're moving along the stream, your boat is moving, stream is also moving in the same direction. So the speed of the boat is more than what it should normally be. So the speeds add. Okay, so this is the first thing. Second thing is, when it is given that speed of the stream is 40% the speed of the boat, so what we can do is we can assume the speed of the boat to be a particular variable or a value, and speed of river to be accordingly. So speed of the boat, I'm going to take this as 10s. So 40% of 10s speed of stream will become 4s. To make the calculation little easier, I can take the ratio of these two and write down 2s and 5s, because it's easier to calculate on 2 and 5 a little more as compared to 4 and 10. Once these two things are understood, that these are the prerequisite part of solving this problem, now we can look at the question. So motorboat takes a total of 5 hours to travel 21 kilometer upstream, which is speed of the boat, which is 5s, minus speed of the river, which is 2s. And the same distance 21 kilometer downstream, which is going to be speed of the boat 5s plus speed of the boat 2s. Right? So in order to go and come back 21 kilometers each side, he takes 5 hours. So from here, we can see that 5 can be written as 21 by 3s, and this is 21 by 7s. So 21 by 3 is 7. So 7 by s, and 21 by 7 is 3. So 3 by s. So this gives us 10 by s. Reason being, 5, so the denominator is same, it's s. If you rearrange, we will have s is equal to 10 upon 5, which will give us 2. Whether it is 2 kilometer per hour, whether it is 2 meter per second, that's not our concern. S is going to be 2. If I put it back, I'll get the answer. Now, once S is known, the speed of the boat is 10 and speed of the river is 4. Now, the question is, how long would the boat take to travel 30 kilometers upstream in the river? So all I have to do is interchange. I don't have to interchange. Time is asked, right? So we can say, as per the question, time taken to move upstream, wherein the distance is 30 kilometers, and upstream speed is going to be 10 minus 4, which is going to be 6. That will result in 5. So C option becomes our answer. Right? So this was, you can see that this was a formula based, and there were a couple of things that we should know beforehand. That's why it took so much time. The previous questions, no formula, faster. Well, that's all for today. I hope you guys got an insight into how we, solve questions. And obviously, before solving questions, before doing all of this, we go through the concepts, very basic things about each and every chapter. Okay, so that everybody is prepared. Well, I'll see you again with another session. Until then, take care. Bye-bye.